So I'm going to start recording, do my usual spiel. This is an open discussion. It's open mic. I reserve the right to moderate, never had to do it. I ask that while you're not talking, you mute so we don't get too much background noise. Yeah, Jason, I got you. This is being recorded. It'll show up live on YouTube and Twitter in an hour or two. If you don't like that, bail out now. Otherwise, anything to do with compilers, language runtimes, garbage collection, I don't know, any typing systems, everything to do with language implementations are all good. All right, a couple more people just show up here. After that, you know, fair game. I'll throw out a question unless somebody has something just to get the ball rolling, but I don't have any set agenda. So does anyone want to throw something out there? Or I'm going to throw something out. So I've been screwing around with integrating Hindley-Milner and forward flow typing analysis and in an SSA graph. So there's sort of two parts to that problem, and you guys can chime in and tell me I'm full of shit here at some point. One of them is just getting it on SSA instead of doing an AST tree walk, which is sort of more mechanical. And I have a bunch of like multi-returns, which I have to treat as single return for Hindley-Milner algorithm. But the actual sort of real thing going on is a couple pieces. One is at a unification point in Hindley-Milner, I do a meet and a lattice. So I don't get a type error, I just get a weaker type. And then I'll look for types that weren't strong enough in the end. And then the other piece of that is, so that impacts the Hindley-Milner type, and then Hindley-Milner lets me claim two types are the same when they have no immediate relationship in a SSA graph. That's the whole point of the parametric polymorphism. And that turns into joining two unrelated types, or unrelated in the immediate graph sense, because Hindley-Milner says these two are the same. So there's some back and forth between the two algorithms. And the theory says there's an optimistic version that's better than the sum of either part. I haven't got that far yet. Mostly I wasn't prepared to go unify memory and sort of classical return value. So this is all being done on memory as well as on sort of standard returns. So I'm treating memory as a first-class citizen. So I'm in the middle of hacking my infrastructure to unify memory state into the standard arguments for function calls, so that I can do a bulk unification.
What is the infrastructure environment? What is the infrastructure/environment you're building it in right now?
This is for my language AA, implementations, redo of C2, sort of a clean up C2 version. So it's sea of nodes, SSA graph built right after, built while parsing. So I built SSA graph while parsing. We got Charlie in here. And then I have a lattice, been doing typing with a lattice and lattice theory and gotten very far and couldn't get parametric without egregious inlining. Basically, I have to, everywhere I wasn't, I can get very far without parametric polymorphism, like much farther than you might expect. I can get a map function doing map function over trees with no types anywhere and no types for structure names, no types for tree structure or anything, and I'll just infer what you meant by the tree and what the map's doing it, including the recursion, using lattice alone. So I can go a long ways here, but I can't go sort of infinitely far without inlining infinitely far, which is not obviously doable in the general case. No, I talk about C2, the hotspot server compiler. That was about the sea of nodes IR. So it's an IR. It's a graph-based IR. So think of SSA on steroids. And then, so then I was looking for parametric polymorphism, and Hindley-Milner has a one-pass, mostly linear time parametric polymorphism tracking, and I finally like wrapped my head around it this last week. It was kind of a fun piece of learning. Like I think I get Hindley-Milner now sort of in a pretty deep way at this point. So it was a fun hack.
Does your SSA implementation, does it use the standard phi nodes, or do you, sorry, experiment with the, what do they call it? I think there's different terms for where the basic blocks have arguments. I think there's,
so it's sea of nodes, there's no basic blocks.
Oh, right. Oh, sorry, I missed that part, yeah.
Oh, well, you're under a different name now under Zoom there, guy. Mark. Fine. Snow, there are standard phi functions. There are no basic blocks per se. You can pick out a control flow graph sort of, okay, fine. You can pick out a control flow graph sort of, right? I mean, it's there, but it doesn't, nodes are not in a basic block or out of the basic block as undefined in that sense.
Right. Yeah, because the standard phi, so is that phi? I guess the opinions differ.
Yeah, everyone does it differently. I don't care. I know what you mean.
Let's say phi. Because there's in Rust there's a JIT framework or compiler framework, I think it does both, called CraneLift, and they have SSA support, but they use block arguments. But it's a technique, as far as I know, it's not super commonly used. I think same with sea of nodes. It's, I think, a bit more of a recent approach, as far as I understand. So I'm kind of curious, sort of what the experience.
I did my PhD thesis.
Oh, okay. It might have been just
a compiler. So 25 years of very widespread use.
Right.
Maybe 30 years.
Maybe recent uptick in sort of publications. At least it appeared to sort of, how would you say, be discussed more.
Yes. Well, Graal went with it, but that's not that new either.
Right.
Graal's been around a while too. I don't know. I fell in love with it many, many years ago. I wasn't the first, but I was kind of the first to push it hard and then pushed it into something that went mainstream. But then you're right. It went quiet for like forever and a day. Oh, V8. Yeah, I heard V8 was using it too. And it went quiet for 20 years and everyone just used it. And no one said anything about it. Like most used compiler on the planet by probably an enormous margin. Fine.
Right. Yeah, because I'm working on a compiler as well, and it doesn't do SSA. In fact, it basically does no optimizations at this point, because I'm focusing more on the language that comes with it. But I've been sort of slowly, because I'm working towards making it self-hosting, so working through porting the type checker over it and actually making it work. Because the one I have right now, it's basically held together by duct tape and parts where I'm like, how does this work? I don't even remember.
Right. And every program is portable. It's not portable until you port it at least once, but maybe 3 times, and then it's portable. Yeah.
And so as part of that, I'm sort of slowly starting to consider, okay, the next steps after type checking are going to be the intermediate representation. Do I want SSA or not? Because this is an interpreted language. But the challenge that I found is SSA takes a little little bit of effort to wrap your head around. But then with sea of nodes and these other techniques, like, not sure which approach I want to take. But unfortunately, the literature is, I wouldn't say limited. It's a bit of a hit and miss.
You can hunt for my name in sea of nodes.
Right.
And you'll get handfuls of papers out.
Yeah, because I have a couple of books that generally people recommended on compiler design, but more on the sort of technical side. But then like half the book is just parsing basically, and then they sort of gloss over type checking. Basically the parts were like, that's what I want to know. And they're like, oh yeah, we can do that, but we're not going to discuss that.
Right.
And
yeah.
It's a bit of a bummer.
Yeah. I like all the thick things on parsing are like junk.
Yeah. Parsing for me, I've done it plenty of times, written my own parsing generators. It's boring. At least to me.
Not the exciting part.
No.
There is a kind of an exciting part about parsing, which most of the textbooks ignore, which is how to handle incorrect code. Because that's where it becomes challenging. I mean, you could do IDE support where, most of the time for while a program is being developed, it's wrong. but the program might still want information about the program. So you need to be able to parse and type check partially correct programs. And that's interesting. And I don't think there's a lot of theory about it. You have these technical reports here and there about people who do it because it is done after all.
Some of the full-on parser generators did some theory, but it's very old now, about sort of minimal error tails, like we'll stop at some point and declare we had an error, and then we'll try to inject typically closed curlies to stop the error stream. You know, if I do this all the time in Java, you skip a closed curly or you add an extra one somewhere, and suddenly from this line on, every single line has an error message, right? And then they cap at 100 errors and they stop. And I'm like, okay, somewhere in the world, the parser generator, somebody should have been able to say, we're fucked up here. Yeah. Let's try to close a scope and see if it fixes it.
But the motivation for that work was that the compiler took a long time to run, so you might as well get all the errors for every run. But that's not the motivation anymore, because the compiler is fast to run probably, but you
parser
are running
certainly
an ID or something.
Yeah.
When you had a 3-day batch turnaround and time on punch cards, that was probably a good rationale, but it's probably less so now.
No, I think it wasn't any rationale on punch cards. That was just like, what the fuck? You know, we didn't think it through. We didn't have time. We didn't know what the hell we're doing. We're just lucky to have a parser that parsed what we thought was the correct text correctly. So, you know, times moved on, and the parser minimal extension theory, I have seen things on, but it's a long time ago. And I myself have spent, it's a hand roll recursive descent, and I spent some time trying to get reasonable errors out, and I gave up, and I'm not currently attempting the inject a closed curly and declare victory approach. But there's something that says I probably want to catch the you're sick now in the parser, and I'm just stop.
Somebody mentioned Rust earlier, and you know, its error messages are so good that I feel guilty accepting their advice sometimes, right? You know, the error message arrives, and rather than a cryptic sentence fragment with a line number, it's more or less a page of practically formatted, indented text that points you to a link to a reference that will help you with whatever misunderstanding led to it. Or
that's that's not a syntax error, almost.
Yeah.
Yeah, see,
no. The syntax stuff, like you stop even kind of noticing in it, because the you know, it's throwing information at you about things rather above the level of syntax, to the point that it's just spooky relative to other things I'm used to.
Oh,
I feel I don't deserve it.
Like I spent way more time trying to get type errors to report politely than syntax errors, because syntax errors are easy to fix. So you're like, oh, fuck up. No, I need my closed curly, whatever, and I'm done. But the type errors, you get confusion in the ranks. Like, what the hell's going on?
I think what plays a role there is also like syntax errors, I think, happen less often than type errors, or let's call them logical errors, because it's not just.
Well, my IDE will just give me red underbars everywhere.
Right. And so they are noticeable. I think the recent sort of interest in language service has sort of changed this idea, like, parsing whatever. So now, you know, language like Rust, for example, they spend quite a bit of time trying to make it so they can do incremental parsing and handle these syntax errors nicely. But I think for a lot of languages, it's just not a priority. Like for my own, I know for a fact, like syntax errors right now, they're horrible, because it's like, there's no point, because there's no IDEs really for it, no language service, and there's not really a language that are people using. So
that's where I'm at. So yeah, like I said, I spent effort on typing error reports, but not so much on syntax errors. There's some, but there's not a lot.
Yeah, I mean, I think it's the same for most languages, but it is kind of the wrong way around, since in essence, the compiler error messages are the main user interface for a programming language.
Yeah,
that's what users will see most of the time, but it's hard and it's not very fun to implement, I think. So
yeah,
that's after you've taken over the world, then you can improve the syntax errors.
Also, people joked earlier about how every compiler's book is 2/3 parsing, and then the joke about the undergrad compilers course is you run on a semester before you finish. You barely finish the parsing part of the textbook when you run on a semester, so the undergrad compilers course turns into a not very good course on parsing. And then actually turning the result of a failed parse into something a human could actually reckon with, well, that didn't fit in there anywhere.
Yeah. I guess if I was to teach such a course, I would go with the least possible syntax language of which I can name one called Mouse from the 60s or 70s as a training one where everything was exactly one character only. And then you could do balanced parens and a couple other things, and it could interpret directly, but you could make a program out of it, and it had looping. It was Turing complete, but no fancy parsing. You're going to write a hand-rolled recursive descent, except it ain't going to descent even. It's just going to be a hand-rolled character at a time parser, and that's good enough for now for parsing. If you want to read more, go read this giant-ass thing book, and then go grab Yak, or write a hand-rolled recursive descent parser, which is a hell of a lot easier than Yak.
And there's a crossover opportunity between classes too, right? Because people probably are taking a theory of computation or formal languages course a term or so earlier. They've learned enough of the theory of the parsing that they can sort of take the theory on faith from that, use a parser generator, and then actually learn something about code generation in 7 or 8 of the weeks of the term, rather than losing that much on parsing.
If I had to do a fancy parse, I would tell them to grab a tool and skip the theory. I personally only ever do hand-rolled recursive descent because they're super easy. That's what I would teach. If I was going to teach something to do with parsing, I would start with, here's a recursive descent. Here's a bunch of theory. Don't bother. If you have to use it, grab a tool. If you have to implement the tool, well, go read these books on this theory. But we're past that point now.
Yeah, it's like with the literature and such. I can't speak for universities. I am self-taught in that sense. But with the literature, I would hope. Yeah, there's probably some book I don't know of where basically everything after parsing is covered more in depth. Like most of they'll cover code generation and some optimizations, but there's this sort of gap in between where it's type checking, how to make a decent IR, how to deal with SSA, and all these different things. And I think I have 2 books, and they both touch on SSA in just 1 page or something. They basically say, "Oh, this is SSA," or "Fine notes, blah blah blah, done."
Oh God!
It kind of read through. It's like, okay, I could have just read Wikipedia for that. Like, this is not useful.
Yes.
The Wikipedia article just cribbed those pages anyway.
Yeah, basically, and there's one where the type checking, like, it is actually like 1 page. They don't even sort of they don't mention Hindley-Milner, I believe, even. It's just sort of a high-level overview of what it is.
I think you'd have to, if you're going to mention Hindley-Milner, you have to head down that path of implementing it. It's an algorithm to implement if you had an AST that you parsed already. Right.
And for me, this is sort of a bit of a bummer, because as I'm sort of implementing this type checker, there are decisions you have to make. You're like, okay, I have an idea, but is this the right idea? Do other compilers do it? And so far, basically, answer to that's basically either just go for it or read through this 10,000 line file of this compiler's implementation, and basically still don't know anything.
Still don't know what's going on. Yeah, I've done a lot of go for it in AA, which meant that I've been very slow getting to where I could run code, because I kept saying, well, I can handle this in the type system. Oh, I can handle this. Oh, I can handle this. And then never ending kind of thing. Trolls, you had a comment you were starting to say?
Yeah, I think the modern compiler implementation books by Andrew Appel, they are very light on parsing and mostly about compiler design.
Oh, good.
So those are pretty decent. I remember being taught from those when I was a master's student. And
are those like new prints of the where was it, the one from the 90s where they had the one in C, or sorry, initially ML, and they ported it to a bunch of others?
Yeah, that's the one, modern compiler implementation in ML or in C or in Java. I think the ML version is the best.
Because the other ones were, I believe,
first.
Yeah.
Matt's throwing a bunch of stuff in the chat for links.
There is a pretty great book, which is a draft, but it's already several hundred pages, called SSA-based compiler design. And I think it's possibly my favorite compiler text, even though it's a draft, because it starts from SSA and then it goes further. So it goes through all of those topics, like constructing the SSA IR form, distracting, then optimizing the distraction, avoiding the unnecessary copy operation. It talks about what does it mean for SSA to be sparse, which is the first book that actually really explained this, at least from my perspective. I understood this after this book. And it talks about a lot of other forms like SSI, the static single information form, the functional representation of SSA, which is there is this classic 1998 paper by also Andrew Apple, and this one I think goes even further. It basically, there is this great side-by-side picture that I cannot really show on
If you have it,
Zoom, but the book is, yeah, it's freely available. Table 6.1 is what I would, correspondence pairs between functional form and SSA is what I would start at. And I think it's a pity it's only one book like that. At least I don't know any other book that starts from basically the middle. Well, it starts from the end of the front end. It basically starts at IR generation and it goes up to and including SSA base in register allocation, for example. So I think it's one of the best compiler texts, if not the best, even though it's a draft at the moment.
that link. Yeah, the PDF pops right up if I click the link. Oh, there's a lot of stuff. Okay, so it's draft. A lot of stuff, though. Vanilla SSA. There you go. Okay, I'll quit looking at it. Right, yeah, bookmarked it. Yeah. It's good stuff. So, Yorick, what's your goal with your language?
Loaded question. Take over all the other languages. No, so it's object oriented. It kind of takes a mix of like Smalltalk, Erlang, a couple of other languages.
So you said Erlang, so that means you have some sort of
lightweight processes completely isolated from each other, message passing, that sort of thing. And yeah, the goal is to sort of compete or be sort of at the same level languages like I think kind of in between like Java and then Python, Ruby, etc. Because it is statically typed, it is interpreted with a bytecode interpreter. But I think it's a little less, or at least I want it to be a little less rigid, I think is the right way of saying, than Java. Certainly less boilerplate. And so like right now, the compiler is written in Ruby. Not exactly the best language for writing compilers, but it's a language I've been using for like 10 years. And I was like, yeah, whatever, we'll do it in that. Because I started trying to write the compiler in Rust a couple of years ago. This was, I think, 2016 or something. Basically, when Rust was like just reaching version 1.0.
What was your experience like there?
So for writing a compiler, I found it quite painful. And that's primarily with ASTs being graphs. It's a little annoying to do in Rust. You can do it with enums and such, and a lot of pattern matching. But it becomes very verbose, quite a bit of boilerplate. And I think I spent like a couple of weeks trying to make it work. And I was like, okay, let's try doing this in Ruby. And I think within a week, I made like much more progress because it's just a lot of stuff you don't have to think about. And of course, you pay that price with runtime errors and such. But Ruby ended up being quite nice to write this sort of quick and dirty compiler. And that way I could focus on the VM, the language, etc.
I'm using Java.
Right.
As a convenient place.
Yeah, and so for like the VM, I think Rust is a really nice language. Like definitely when I started, it was a bit of a bumpy road because a lot of it was still solidifying and certain functionality that you would need wasn't there or marked as unstable. So for example, the raw memory allocation APIs were marked as unstable, which meant that you couldn't build it on like the stable Rust that most distributions ship, which makes it a little more difficult to get people to use. And then they went through like 2 or 3 iterations of those APIs before they were made stable. Nowadays, it's pretty great.
Do you need raw memory? In a compiler, do you really need raw memory access?
No, sorry, in the VM for the garbage collector in this case. Because the approach people are doing in sort of stable Rust is basically to allocate a vector and then operate on roll pointers to that memory. But that doesn't give you control over alignment and that sort of thing. And In this case, the garbage collector is based on Ibix, and they, I'm not sure mandate is the right word, but they, in their design, memory are blocks of a certain size. I think in the paper originally it's 32 kilobytes. I use 8 kilobytes, but it's aligned memory, and that part is quite important for certain operations the garbage collector has to do. But so nowadays it's pretty great. I think really the only thing I miss is some form of support of computer goto, because for the VM interpreter loop, right now the only approach is a loop and a switch. And LLVM doesn't optimize them to computer goto. It just becomes a jump table, which is pretty decent on modern hardware. But I think the commonly sort of found difference is that computer goto is like, I think like 5 or 10% faster, somewhere in that range.
Yeah, GCC would use label bars.
Right.
You get a, yeah.
Yeah, there is a hack somebody did like 2 years ago or so, an experiment, and they essentially managed to do this by using raw assembly instructions. But that becomes super fragile because Rust, raw assembly, and LLVM don't always play nice together. Like you have to be very careful on how you clobber certain things in market, etc.
The hotspot VM generates the assembly at startup, generates the interpreter at startup. Get that right. And it's just a full assembly based interpreter, but then you don't get any direct access to like LLVM. You have a bunch of handoffs to make sure that it's isolated in that sense.
Right. Yeah, but mine right now is just the interpreter, because that was the other thing, like if you want to, for example, write a JIT, there's LLVM, but it's a heavy project to use.
Yeah, I'm talking to a lot of folks who are annoyed with LLVM for JITting. Yeah,
and I helped maintain a Ruby implementation for a while. They used LLVM, and I just remember all the trouble where every minor release APIs change, and then you have to deal with like distributions being behind years. It's really painful. And this was, I think, right around the time they were introducing LLVM 4. So they had the old JIT API of LLVM 3. They introduced a experimental one called, I think, MC JIT. Then I think one major or minor version later, they deprecated that one, and I think they introduced Orca, as they call it. And then I think now there's some sort of hybrid. So they went through a couple of different APIs that were incompatible. And with that in mind, I was like, okay, I don't think I can sort of mentally deal with that. But there aren't really proper alternatives. There's GCC JIT, which I think at that point was somewhat unmaintained. There's libjit, I think, also kind of unmaintained. And so I kind of sort of shelved that, like, we'll do that when people are actually using it. Nowadays, at least for Rust, there's CraneLift, a compiler and JIT library. It is focusing quite a bit on WebAssembly, but it's not its sole purpose. It's just that's what people use it for today. And that looks quite interesting. I think it still has a long way to go. I don't think they optimize code right now, but the foundation's there. It's called CraneLift. And I think now there's some others. There's MJIT, which was developed, I think, with the intention of being used for Ruby.
Can you throw any of these things in the chat? Even just the name, people can search for
yeah, sure.
CraneLift in the chat and
MJIT.
CraneLift, got it. Yeah.
CraneLift.
Mentioned GCC had one. I hadn't heard that.
I'm not sure it was GCC JIT. I recall this one. I think Firefox used to use it for up until like 5 years ago or so. And then there's one which is basically using GCC, but in sort of a JIT setup.
The hotspot had two, now we call it 3 JITs, C1, C2, Grail, Grail. And the API went through a whole lot of iterations, mostly because we didn't know what we needed to track, and we weren't have any tracking support baked in. And so the first trick was invoke the compiler on this method, and then it was invoke the compiler on this stack trace with this method at the top, and you had a stack trace that you were crawling through, and you went inline, and then, oh, I need to have all this dependency info and unwind, and each compiler did it their own way, and then you wanted to plug and play, so you had to go back through and wrap an API, and then there were several other things that were mistakes that weren't recognized as such until much later. They had it redone. So yeah, I totally get the APIs needing to go through several go rounds. You know, one of the funny ones was the compiler would ask a question of the runtime about the subtyping situation, the class hierarchy situation at one point during the compilation. Then, because it's running on another thread, a little while later, it asks the same question again. But by then the situation's changed. So it asks the same question twice in a row, gets a different answer the 2 different times it asks. And the compiler is all assuming sort of a static universe at the time of compilation. So it's not expecting a different answer. And so now it proves false as true, and then it collapses on itself from there, and you crash and burn and die. That went around quite a while until we recognized it's not just, if you ask a question, you have to ask you have to give the same answer back for that question, and every question that can be derived from that question has to be answered the same way, or the compiler, theorem proves false is true and you're dead.
Well, this is useful for asserting sanity and asserting different invariants. But in fact, if you do invalidation of the checks, invalidation of all the questions you made at the time of installation, you would not install this contradicting compile.
Yeah, so it was never right. It was never a case that you installed the broken code. It was the case that the compiler segfaulted itself.
Ah, okay. So my point is, it's not a correctness requirement. It's just a very useful thing to have, so you can assume something or assert some sane invariance in your compiler.
Yeah, the information is used to optimize. The incorrect information was crashing, but if you didn't crash, then when you got to the end, you failed the correctness checks and you just threw it away. It was all fine. Mostly we were trying to not have the compiler crash during its runtime. And you could argue the correct thing to do is let the compiler crash and just clean the thread up and clean all the memory state and go again, and you didn't care. And that would have made life a lot simpler. We tried to handle a bunch of things because we thought it was a bug in the compiler, but you kind of could lift the situation, say, because it's concurrency, it's not a bug in the compiler, it's a bug in how you invoke the compiler and the right.
Well, and often situations you can have when you have some contradictions from different queries to the VM, you can have similar situations in dead code, which is legit situation. So it's in general, you want to be robust to this kind of contradictions, because you may see these contradictions from dead code.
Right, and so C2 got pretty good about being robust in dead code in particular, because we would just assert things, we would check for stupid situations and then not die. And then if you continued execution, the dead code would clean out and the stupid would go away. But we had to catch a lot of stupid. And we backed that up to, well, why did we get here? And why we got here is because we saw contradictions on queries. Can we do something about that? So we went and changed the API to try and fix contradictions so you didn't get contradictory queries, which you probably should be living with, Arthur.
Yeah, it's well, short answer, yeah, we still have the same invariant that we get the same answer if we ask more than one time.
Right, so you're already living with a sensible answer there. Oh, we can see behind you, Cameron. No good. I still see behind you. And you have no sound. You're muted. Well, I can see he slid this backdrop back and forth 3 times trying to cover the corners. It didn't work. Yeah, like me, exactly.
Looked like he was rolling a boulder.
Right.
What's weird is it's blue in this picture, but it's actually green.
Oh, well, your shirt's not the same color, and so you have a body today.
I have a body.
My camera has such poor color balance that I'm inheriting the skin color of the green screen behind me, so I just get this jaundice that's somewhat exaggerated.
I just thought you just hadn't been out in the sun in a while.
Well, that also is true. My actual skin tone is light gray, because I live in Seattle. So
There is that the old Dilbert with the pale
Yes.
Whiter shade of pale and new mint green or something.
New mint green sunscreen. Yeah,
Yes.
yeah,
I'm one of those Pillsbury products that hasn't been broken out of the little cylinder it comes in from the freezer section.
yeah. Yes. All right.
Nobody wins, so I guess nobody's seen those.
Okay. We're talking JITs and JIT interfaces, Cameron, but I don't have any. I don't know. We're winding that one down.
I like JITs.
Are you using Llvm?
That's the plan. We're not using it yet.
Okay. What are you doing now?
We're still refining the instruction set in the so the IR. We have our own IR.
Yes.
So then the idea is to translate that into Llvm IR, but
Okay.
it'll be dramatically different.
So you don't have an execution strategy right now, or you got an interpreter.
We have a strategy in the sense of we have a desire.
Operational execution model, an operational one.
So right now we use a proof of concept interpreter, but the IR is not intended to be interpreted, so it just sucks really, really badly.
Gotcha. Yeah, I've been debating with my first plan of whatever, proof of concept. Like go execute CF nodes directly. Well, CF nodes is definitely not meant to be interpreted, so that's gonna suck as well. So I don't know what I'm gonna do there.
Well, most instruction sets have a very small number of primitive types that they focus on. I mean, you go back to assembly for x86 and you had, DB defined byte, like.
Right, you had sizes 1, 2, 4, 8, and then you had int versus
8.
float.
No, we had 1 and 2. Yeah, there was 4. Okay.
I mean, even on
much.
Z80, oh, maybe not. I could get, no, you're right. On Z80, I capped out at 2. It's true. Fine.
Yeah, but you could learn it in a day, so.
Yeah.
So
right, but this is an IR, so you don't need to think about assembly.
Right. Well, that's the thing. So our IR is completely OO for all practical purposes.
Okay, fine.
So it's almost a transliteration of the code into an IR.
Yeah.
Not accidentally.
Yeah, that's fair. Right. And for me, the SSA form, that's sort of easy operational, except that the semantics of the types will be the full lattice, and everyone will just like bail a runtime fault if it's not a thing they're supposed to be handling. But that's the obvious implementation strategy. Multiply will accept every possible type, including pointers to strings and pointers to structs and whatever. And it shall blow up if I got the typing wrong. It's fine.
So have you done any work with Llvm?
No. I talked with those guys from when they first started it on and off forever and a day, and I never bothered to actually do anything with it. Because it didn't work it wasn't available really for C2, but it also wasn't available in the correct way for a long time. And now it is, but it wasn't.
It's only really become practical the last year or two. I don't know.
Only the last year or two. I didn't say 5 years, maybe.
No, I don't know, Art or Matt, if you have a different opinion, but
Well, it depends on what part you need for your JIT.
Yeah, the Java memory model correctness, like the register allocator forever and a day would simply spill code without regards to the memory model, and then reload from like home locations is totally classic C register allocator hack, which would break the memory model. And then tracking pointers for moving GC code and things like that.
So support for GC pointers, we introduced that maybe like 4 or 5 years ago.
Okay.
We also introduced support for deopt metadata. It was like probably 3 years ago. We didn't do much in terms of JIT support. The parts which we have touched on like recently was org.jit and other things. Just because we are using the existing VM, we are using the existing infrastructure. We just need the We just need that native assembly, and we can execute it without any LLVM support. So this part might be lacking. I don't know because I haven't worked with it.
Okay. Yeah. Look at this stuff here. The other thing to think about is I might go straight to code gen with a very dumb, bad, easy backend. No, I think I'll probably do execute on SSA and graph directly. First cut. It'd be stupid, it'd be slow, but it'll let me write enough code. Rejects code like single leg. Yes, you shouldn't have a single leg if. You have broken the graph, Zen, if you have a single leg if. So those show up as partial optimizations. So you have a broken optimization if you end up with one that sticks around any length of time.
What's the meaning of partial optimization?
You have changed the graph structure.
Yes, I did. So that I end up like this kind of broken graph. I understand that, but actually, I mean, in the final reshaping stage, actually, I can correct it. But I found that C2 reject it. It just say that I don't want to do anything about that. So.
No, okay. So hang on. So as soon as you have broken graph, you walk this line that says, when do I catch the things that it's broken? So because you have a broken graph, it is possible that you'll catch it somewhere there. It's possible you won't catch it at all and you'll omit broken code. And it's possible a compiler will simply seg-v on you. So, and I guess another interesting fail mode is it proves false as true, and he happily eats your entire program up. You get the empty graph. That's another common fail mode. So you need to fix the transformation that led to having a broken leg.
Mm-hmm. Yeah, I did. I successfully found the problem. I fixed that. But my point is like this. So why not C2 fix that on their own, on its own? I mean, actually, C2 can fix that. You know, because this is dummy, and I can generate like code to correct it automatically.
Yes, so slow down. So the meaning of this program piece is ambiguous, and you cannot be corrected in that sense because there's a test, and if the test goes false, you have no code there. So you jump to undefined on false. Oh, okay. My cat's trying to be annoying here. Okay, so you're broken already in that sense. Now, if you're here because you have shown that the test into the if, the value in the if is only ever true, the C2 optimizer will fold it up anyhow. You don't have to do anything more about it. It'll simply say, yeah, if true is true. It's all continuous straight line code, and it's done. And it'll throw the test away as a don't need a tester anymore because it's a constant true. But somehow you have a non-constant into an if, and you're missing the false arm. So you are broken.
I got it. So what you are saying is that theoretically, I cannot find a correct way, the way to correct it, right?
No, because it's too late. Yeah, you're too late now. You should have not got there so easily. If you're dead from below, then the true side must be dead from below as well.
Yes. Okay.
And if it's not, you weren't dead from below, basically.
Yeah, I got it. Thank you.
And then LuaJet. I have no idea. Oh, this will be okay. I don't ever do anything with Lua.
Lua is a very interesting language because it's very, very tight. It's very small, and LuaJet is like a very small self boot like a VM Lua for Lua. So everything is there. So that's why I feel that LuaJet actually can generate a pretty decent code, and it has like some kind of decent optimizations. So it's worth to look at. The good thing is there's only like less than 10,000 line of code. So that's why it's very attractive.
I actually don't know anything about the language Lua, other than it's used in a lot of gaming scripts.
Yeah, exactly, games.
And I'm curious. I'll look up Lua in a minute here. Like,
Yeah, I believe Lua JIT in the context of JITs is kind of considered to be this sort of how do you call, like a art piece, in a sense, like people are so impressed by it, and it does generally do a lot of really good stuff. Especially considering Lua as a language, I think it's about as dynamic, or at least close to like Ruby, for example. So in other words, essentially everything can change at more or less any point in time. And Lua JIT does a really good job at optimizing that.
Okay.
When I looked at Lua JIT in the past, I thought that the one major complaint I think people had was about, I believe it's a tracing JIT. And I believe around loops and things, that's where it was falling down in some cases, where you could have some very crazy differences in performance based on run to run. Like the variation was really high because if it didn't happen to go down the right path for an array in this case, or something along those lines, I forget exactly what it was, but there was a lot of inconsistency sometimes from run to run in your throughput. But when it does get through everything, it does a really great job. But
yeah, I'm not saying that it's perfect. I'm saying that, if you want to take a look at how JIT works, so this is like a very, very attractive project to take a look at, because the code is compact, so it's very easy to pick up.
Yeah. Fine.
Yeah, I think like Lua JIT, I believe the development of itself has sort of slowed down because the author, I believe, kind of was just done with it. I'm not sure if they quite vanished, but more or less from what I understood. And so it is running behind a couple of versions of Lua nowadays. I think it's based on like Lua 5.1, I think, and Lua these days like 5.4.
No, there's a Lua 6. I just stared at the.
And there's quite some differences.
5.4.1 released. Okay, fine. Where did I get? Oh, from 3.6. No, 5.4.1 released. I was hoping to get an online tutorial like most of the languages have these days, and I get a reference manual. But I don't want a reference manual. I want like the 2-page Lua for Dummies thing to go scan through. No, instead I get the damn. Fine. Da-da-da.
Yeah, I think Lua is one of those interesting languages where it has quite a big impact because it's used in a lot of video games, for example.
Yeah.
But it's at the same time a little bit of it's not very well known. If you ask the average programmer, they might have heard from it, but
I've never
probably
used it.
don't know what it looks like.
Right. Yeah.
Even though they've probably interacted with something that uses it.
Yeah, in retrospect, Lua was one of the first programming languages that I encountered because it's used as a scripting language in Baldur's Gate, which I played as a child. So, although I had no idea that it was actually an actual programming language at the time.
Oh, sure.
Yeah.
I'm busy reading the top level get started docs, and it's just explaining like every kind of basic sort of, it's like a C level and style thing. It's not C code, obviously, but it seems to have that sort of flavor to it.
Yeah, the syntax is, I think, a mix of what's the language called? It's the same parent language Ruby derives from. I forgot the name, but in other words, very keyword heavy. So instead of curly braces, it's like end if whatever.
Right. There's curly braces, but there's sort of the classic C style thinking of things.
That'd be algol.
And the other beauty of Lua is the simple things, the simple design. So actually, Lua doesn't use like object oriented. Actually, it uses like a prototype, just like JavaScript. So that makes things really, really simple.
Okay. Well, I don't know. It goes both ways. I mean, I've screwed around with prototypes. They have their.
Yeah. Lua cannot do something like a very big project like business-oriented applications, but Lua is very pervasive in the game industry. So actually, just like your C2, so Lua got his job pretty good. So he finished his job pretty good, very good. So that's why I feel that this is very good in design.
Yeah, I think for the purpose that people use it for, I would argue the object model doesn't really matter, whether it's OO prototype or something else.
Right.
My language actually was prototype based internally. I didn't expose it through the language, but the VM uses it. And it sort of largely originated because I had sort of trouble trying to wrap my head around this idea that it being object oriented, ideally everything is an object. But you end up with this problem like, okay, you have an object that has a class that is also an object. So you get that sort of loop going.
You need class to class, right? Class.
And then you get things like, meta class and all that stuff. And I always felt it was a bit of a hack, or at least an approach that I kind of didn't want to repeat. Okay. And so I went with prototypes because the idea is very simply, you just have an object. That's it. You can give it a parent. That's it. But I'm actually moving away from that because it's optimization-wise, it's tricky to deal with. Yeah. Because you end up, like they do in JavaScript, essentially having to generate classes for it on the fly.
Yeah.
And I found that in my case, because I didn't expose this directly in the language, its benefits weren't really there. And I kind of reached a point where I was like, I might as well just essentially use classes internally in the memory layout and such.
And be done. Yeah. So I want to comment here on the last link from Matt. That page is all text, but a third of the way down, they get into the compiler IR, high-level compiler IR discussion, and the tracing jet. So this is like a decent top-level overview of what be done in the compiler. And the other thing is that I've kind of put my head into, I'm going to have classes for everybody, and everybody has a class. For similar reasons. And then I have to decide how much I'm going to let people fiddle with classes directly as a class thing. And that's the whole Java issue with class loaders and the like. I don't want to go down that path either for the same kind of reason. It's way more complicated than necessary. So right now, my current theory is a class is just going to be a standard object that someone's declared as their class. And we'll have fields in it that you can virtual through if you have children that do extensions and stuff, and I haven't sorted more on it. There's something I want to do with single inheritance classes that makes sense. And implementation-wise,
the key is to not have any accidental behavior, and that's where a lot of the designs fall apart, is that they don't specify something, they just let it kind of evolve, and then it naturally becomes a mess. So it's almost like there's no wrong answer other than not having an answer, because not having an answer is an answer. It just happens to be the wrong answer.
Yeah. Okay, that makes sense.
Yeah, for me, with the whole sort of class recursion going on, like in my language, there's no inheritance. You use composition instead, so that kind of gives you more options to try and sort of hide the messy details. But I'm currently sort of leaning towards just saying, well, classes themselves, they just don't have a class, at least not exposed through the language. Internally, you probably have to kind of try and figure that out.
I'm going to go with the class as a self-recursive top loop.
Right.
Class is its own class.
Yeah, and that's that's what a lot of languages use, and I think it's a solution. I'm just not really a huge fan.
You're not a fan
myself.
of it. Yeah, I'm not terribly a fan of it, but I don't know the right answer. To say no class puts a bunch of tests in funny places.
Right.
But if you're going to walk the class hierarchy, you're going to stop at class, and you have to do a self check anyhow. That's your
and that's like if you want to look at methods and such. If you have static methods, you're gonna have to look this up somewhere.
Mm-hmm.
At least in my language for now, I sort of at the VM level, there's no difference between static and instance methods. So theoretically, you could call a static method on an instance of something. It's kind of like how Python does it, I believe.
Mm.
Which, again, it's not exposed through the language, but it means that in theory, I wouldn't have to have this class loop at the VM level,
Mm-hmm.
because a class at its instance would just use basically the same vtable, for example. Which I think some people could argue that is also kind of like a hack. The answer is probably yes, but just sort of a different angle to it.
You have the class loop somewhere. Either it's in the VM or it's in your class hierarchy or something. Yeah. Yeah. For me, I don't have instance methods per se. I only have fields. All functions are anonymous, and you just assign them to a field. You do a final assignment, then it basically becomes a class. It's just the lookup table can be done on the class game. The lookup table does something to say that all of these guys all share a common lookup strategy, which involves going to your class field and grabbing the common field. Like the namespace is local things, and then you go search the class namespace, pick up the next bits.
Yeah, I think sort of to add to that with prototypes, I think for me it always struck me as maybe not a flaw, but like it has support for essentially infinite inheritance, in the sense like you can have a parent of a parent of a parent, etc.
Mm-hmm.
I think in practice, most programs don't go further than one parent. In other words, instance and whatever they are an instance of, and that's it. At least I think certainly in JavaScript, I think in 10 years, I haven't seen any program where you have like a child of a child of a child, blah, 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 and it goes on.
This is
But
a
because
thing that
sorry, go ahead.
This is a thing you can go ask the interwebs for. A bunch of people did a bunch of research on a bunch of these languages on broad GitHub open source projects, and have a lot of these kinds of numbers. I don't know if this one's there, but a lot of these kinds of numbers are available. And
Right.
like the max case is always shocking. The common case is usually what you expect. It's 1 and 2, but you have to handle the max.
Right.
So
Yeah, and that's my problem. So if you have, my point. So if you support prototype, for example, you have this language where, let's say 99% of the cases, people are not going to do this certain thing, but you still need to take into account and optimize for it because technically you support it. And that's for me why I also decided to slowly move away from prototypes, because you end up in the VM having to support, for example, looking up methods in like theoretically infinitely number of
Somewhere
parents.
you have to implement code that goes, I failed all the easy, quick things. Now I have to have a plan which spins in a loop.
Yeah, and the thing is, in my language, it never goes beyond 2, because you have an instance and a parent. That's it.
Okay.
And
yeah.
And then you kind of reach a point like, okay, prototype helped me get to where we are today. It made it easy to think about, but it's time to get rid of it. But on a VM that's 5 years old, it's not that easy, because there's a lot that you have to change for that.
Right. Yes. Well, that's the engineering the damn thing, so that you can keep making changes is the part of half the hack. The hotspot subtyping check has a fixed length table. Hi, Jorn. It's going to get me tomorrow too. The subtyping check has a fixed size table of length 8, and it has to have a range check. It says if you're more than 8 classes deep, then I have to do something ugly. And otherwise you do a table range check and then a table load and a compare, and you're done with the subtype check. And in fact, there's optimizations for all the common cases, but these standard, I have an X and a Y, and I don't know either X or Y at compile time, and I have to do the lookup, then there's a range check of a table of size 8. And if that fails, then we go do something horrible. So there is, in fact, a bailout case for people getting like stupidly deep class hierarchies. And it happens in the JDK even, they're there, they're just not commonly used.
Yeah, so I think for like class hierarchies, especially in the language where inheritance is sort of the primary way to compose things together. Deep hierarchies, they will happen. I think for prototypes, because you kind of do it, dynamically. Like if you take a look at average JavaScript application, even before they introduced classes, people would still have sort of a class, which I think usually just a function that returns an object. That's it. But they wouldn't go, at runtime as the user clicks on buttons, whatever, start constructing these bizarre inheritance chains. But still, V8 and all the others, they have to optimize all of that because there might be that one person who does that.
Yeah, I wouldn't worry about optimizing, but I have to handle it.
Right. Yeah.
That was sort of my philosophy forever and a day on these compiler hangs. Is you have to handle it, which is half the work. And optimizing, if somebody was to do it, you could think through and you knew what you had to do, but it wasn't worth it because no one did it, except that you had to handle it because someone did it. It's ugly. Fine. Right, and so having fewer, I think the moral of that story is having the fewest possible corner cases is what you want. I think it goes hand in hand with Cameron was saying, if you don't think it through, something will happen and it will be a corner case already, and then you'll get stuck with something ugly and you won't know what you want to do. Okay, so either you or Cameron are doing something with I know what you're doing with modules for Cameron. What are you doing with modules? Are you doing anything with modules?
Sorry, you're asking me?
No, I know what you're doing, Yorick. What are you doing for the new language guy?
Oh, sorry.
I kind of have a feel where I can see.
Inco, right? Inco
sorry,
is the language?
What's the
Inco?
language?
Yeah.
Throw it in
I'll
the,
type
go to
it
the
in
chat.
Well, I'll get the website. That's probably even easier. Hold
Yeah,
on.
throw the link in the chat.
Because there's oops. So modules, they are kind of like the Python sensor modules. They're not ML modules, like you cannot parameterize them.
Okay.
I've mostly just haven't really found a use case for that, so that's why.
Yeah.
But they too are basically just objects, happen to be instead of a module type, so it's not overly shocking.
Okay.
And see, modules. Yeah, modules used to be sort of kind of hacked together. Like the compiler basically generated the objects for them, sort of hidden pieces. But then a while ago, I made it like a first class part of the VM because it made a bunch of things easier, like simply getting a list of modules. Originally, my idea was, hey, I'll do that in the compiler, so I can sort of separate VM and compiler. This was back when I still had the idea that VM could be useful for other languages. But then you sort of, as you develop, you find this sort of intermix anyway. And I found like this is maybe a little too much to do in the compiler. Plus, basically any language probably wants modules anyway in some form. And then you move it to the VM, and it's made a lot of things a lot easier. The language in general, I quite interesting because it started as more sort of Ruby-like, in the sense like quite dynamic. It was actually gradually typed, and then over time, as I sort of dug into it and worked my way through it, I kind of realized, okay, this is actually, at least for what I wanted to do, counterproductive. Especially gradual typing, because it's, I think, a very interesting concept, but when applied to dynamic languages. Whereas my language, it was sort of static by default, and you could sort of opt out. The idea being like, hey, if you want to make a quick script, you can just use dynamic typing. But if you want to have a big program, use static typing. But I kind of reached a point, it's like, okay, if everything's statically typed by default, if you have this piece of dynamic code, it's sort of isolated. Like you can't pass a dynamic type to something that wants, say, a string. And so it ended up not being particularly useful. And it also inhibited quite a few potential optimizations. So for example, because they would allow dynamic typing, you would also be able to call a method on a dynamic type, which means you don't know how many arguments it needs at compile time, or if it even exists. So you end up with a compiler that's doing type checking, and they have a certain degree of runtime checking. Hey, do we have the right arguments? Does this function take a variable argument count? Language also supports keyword arguments, so you have to map those to the positional arguments, etc. It's just a lot of work where I kind of looked at like, this is not worth it. Like, people probably aren't going to use it that much. So I essentially just scrapped all of that, made it statically typed. And because it already was that for the most part, language-wise, very little had to change. It just meant I could remove quite a bit of VM noise, so to speak.
Yeah. Yeah. Okay, so now I'm looking at your error model.
It's basically checked exceptions, but without the headaches. It's a very strict model of it. So sort of the elevator pitch. Basically, if you throw, you must tag it in the method, but you can only tag one type. Although you can throw a trait or an interface. And then when you call such a method, you have to explicitly use a particular keyword to sort of indicate like, hey, this might throw. And then you have the option, you either just rethrow it and then all the same rules apply, or you have to handle it.
This is Java checked exceptions.
Essentially, yes, but without the without having a runtime exception that you don't have to annotate, for example. Or was it standard error, the base class?
Runtime exceptions you don't have to annotate or catch or do anything with. Yeah.
Right.
Yeah.
So in this case, you have to do all of that. So if a method throws, there's no way around not handling that.
Okay.
I kind of stole that idea from Midori, this sort of experimental Windows operating. Was it operating system?
Duffy, yeah, Joe Duffy.
Yeah.
It was
I'm reading this for Duffy.
Outgrowth from the .NET project.
Yeah. And so I basically read that blog post like, that's a great idea. I'm going to steal that. And originally I was a little uncertain, knowing checked exceptions have been tried and generally aren't liked. But I found at least the setup that I have works actually quite well. And I think part of it is because you can only annotate a single throw type. So you won't have like a list of, oh, this method can throw 200 different things.
Well, the no runtime error exception is crucial because the common situation for Java people is they don't know what to do with the error. They think they can handle, but they at some other level, but they don't want to annotate it either. So they just recast as a runtime to ignore the problem. And I do that all the time when doing JDK work. I get a funny exception. As far as I'm concerned, I want the program to die.
Right.
Just die in the debugger and I'm going to go fix my bug. Fine. So I don't want to deal. So I have to make it disappear.
Right. Yeah. So there's a mechanism where if it throws an error, you can decide to just terminate the entire program.
Right.
The challenge that I always had with the checked exceptions is that the caller and the callee, as long as they know each other, everything's fine. The problem is when they don't know each other, you're screwed. And this happens with interfaces. So I have an interface called, do something, right? And it's got one method called do, right? And, someone implements it on top of a file system. So there's an IO exception. Someone else implements it on top of a database. So there's a JDBC exception. And someone else implements it on top, and so on. So it's like, which exception do you declare that it can throw? And you end up with two choices, exception and runtime exception, right? So, so you're it's basically like, it's kind of the diamond problem in a way, except it happens because of the anonymity of the interface from both the callee and the caller point of view. So,
right.
but it affected, the situations I had in Java, but it's also just as possible to be language. There may be a language specific problem.
So I've taken sort of a hardline approach, and I suspect at some point people are going to give me shit for it. But basically, at least in the standard library in its current form, it primarily just uses a single error just called standard error. And in this language, stack traces are not generated by default. So they're quite cheap to throw values. What you could do is in your interface, you could say, hey, this throws not a concrete type, but whatever implements this other interface. And then you can have these different methods throw different things, provided they match this common behavior. I suspect some people are not going to like that. So far, it's working out surprisingly well, actually. Like, for example, I/O, a lot of language still throw like different exceptions. So you have like air no, e no, whatever they are.
File not found versus disk full versus whatever.
Yeah.
Right.
In this case, the language just throws standard error. Like, and the error message is just a string, which it works well enough, I think, because there's always just one error. So you don't have this case of like, oh, if we have, eno this, do that, eno that, do that. Because at least from my experience, most of the time people don't sort of care at that level of detail. They just want to say, hey, do this. Or if there's any file error, do that other thing. But yeah, it remains to be seen, like, if this scales to like really big projects.
So say it again. You are taking whatever exception and you're mapping it to like a string.
No, so in case of file errors, for example, the VM basically right now it takes the error code and turns that into a error message.
Mm-hmm.
I've been considering maybe attaching also the error code, which haven't done it yet. And then it just essentially throws that wrapped in a sort of error object.
Right.
So
throwing an error object with a base is like a Java runtime exception.
Yes, essentially.
Okay.
Just minus the stack trace.
Yeah, fine.
You could add those with your own sort of error object. But in theory, you could just throw an integer or just a string. Like the language doesn't really care what you throw as long as you annotate it appropriately.
Okay, but then each layer above has to say, I acknowledge the throw.
Yes.
Okay, or I'm going to catch that.
Yeah, and so that is a bit of a it might be undecided, as in if you have a method 10 layers deep that throws, and all the methods that call it don't really care what to do, they just want to rethrow it, you have to annotate every single one of them.
Right.
It does sort of leak through your APIs, but I think that's no different from a method returning something.
But you only have one exception that you just throw or you didn't.
Yeah. And so the scope, or let's say the damage that it could potentially do, is, I think, fairly limited.
Your API calls all start. Your calls that are subject to the runtime errors are all said some keyword after them, and this guy throws.
Yes. So it is. I think you can sort of keep the damage under control because it's so explicit, and because it's so restrictive.
Okay.
But at some point, you can always decide, like, look, this error, we just want to terminate the program.
What do you do with array out of bounds exceptions?
Out of bounds, they panic. For arrays, if you do an out of bound, you get a nil. Although I'm planning on changing it to like an option type. Byte arrays, they will panic. Sorry?
I've dealt with Llvm, which all array references return you an option type, and that totally sucks to use.
So that originates from this idea that right now the language has nil, like Ruby. I think the Smalltalk, Objective-C did that, where if you send a message to nil, it will just return a nil. That's what I do as well, except if there's a method for it. And that way, if you, for example, work with like a deeply nested array, you can just access the indexes as such. You don't have to check along every single step. And then towards the end, you can say, hey.
Consider that good? Just failure? Or is that considered a missed
So it is, I think it depends on what you're doing. But it's a pattern, for example, with a lot of language lately, like Ruby has it, Kotlin has it, where they introduce these operators where...
Right, it's as opt-in, but as a default behavior, it seems dangerous.
So it's not dangerous in the sense that you can't pass nil to some random type. So if you have, let's say a deeply nested array, you want to just access, index 0, 1, 2, 3, etc. You write that as if the values are all there. And then at the end, if your method returns an actual value, you have to then say, hey, are we dealing with nil or none or whatever it ends up being, or do we have an actual value? And so it sort of stays within the appropriate boundaries. It doesn't like leak all over the place.
But I think it's something. If I run a Daxby loop, right, and I've fucked up, and so I'm going to have an index out of bounds somewhere. You're going to pull elements out of the two arrays and multiply and sum, or whatever the hell we're doing with our BLAS loop here. At what point do you recognize you've screwed up and you're now propagating nil endlessly? And that goes right down to the code generated in the hot loop for a DAXB.
Right. Yeah. So there's cases where this might not work. It may. I haven't seen cases where it's like a huge problem. And especially with nested data structures, I quite like it. You know, that's my.
Okay. So same thing. You know, one of the trinary guys, I read two arrays, multiply, and put the result in the third element by element. I screw up. When do I start clunking nulls down in the third, which is an array of doubles and doesn't think it should ever have a null?
I'm not sure if I entirely follow, but so sorry.
So imagine I have three arrays, two sources and a dest. I've screwed up one of my sources is of length 0 by mistake. The other two are length 1,000,000. Now I run a million loop where I walk the two arrays, loading two elements, multiply them, store them in a third. Really common graphics library kind of transformation. Okay, and what shows up in the third array, and when do I recognize I'm screwed up? Do you put nils down instead of a double?
Right.
Because
I mean, it kind of depends on how these arrays are typed. For example, like if they are.
I want them strongly typed as arrays of doubles.
Right. So if you declare them as doubles, the compiler will say, like you can't push a nil into an array of doubles. Okay,
so they're strong. So then how do I, when I write the code for the loop, I load an element, and what I heard you say is I load an element, it could be nil or double. I load an element, nil or double. I multiply to get a double, and I want to store.
Right. At that point, you would have to check, are we dealing with an actual nil or a double?
So the compiler has to have in the hot inner loop or a range check that these two loops are compatible array length and compatible with the loop. Because the semantics.
Right. So the compiler doesn't do the compiler itself doesn't do bounds checking. Essentially, the way the system works is if you have a type that is X or nil, the compiler inserts some code so that whenever at runtime that thing is nil, it just sort of produces a. Sorry, I'm saying it correctly. Yeah, when it's nil, it will just produce a nil and basically skip the call, unless the method is actually defined.
So the store is a call that would get skipped because you were trying to write a nil.
No. So let's say, for example, you have an array of, let's say, strings, for example.
No. Do an array of doubles on purpose because I'm trying to break you. So it's how you're not broken.
No. But so to illustrate, so you take, let's say, a string, you want to, capitalize it. If that thing is nil, it will just skip the whole capitalized call and just return nil, unless nil actually itself defines it.
And then in the destination array, when you write the result, you just wrote a nil.
No, so because if you type the destination as, let's say, an array of doubles, and you have an input that is, X or nil, the compiler will force you to do something with it. Like you have to somehow check.
Right, and so this is where I played with this format in Elm, and it totally sucked because I knew my arrays were the correct size. They would never range check, but I had to test for a nil that could not happen. I had to have a handling for the nil, which could not happen. So handling was nonsensical because it couldn't happen. And then
for the case like that, there is an operator, like an exclamation mark at the end. Not too happy with that particular operator, but that one, it will just tell the compiler, go away. This is not nil.
And if it happens to be nil, the compiler, what's the semantics? If it is nil,
right now the VM will crash.
Okay, so it's a panic panic if nil.
Yeah. Also, it doesn't generate code, but what happens is when you use that operator, the compiler just treats it as X instead of X or nil. So if you have this algorithm where
that's
okay,
fine. I claim you're unsafe then. You don't want to cheat that way. You want to panic, but you have a character throw the nil away.
Right now the VM will crash. But the
you say
plan
crash,
I have,
but think security hole.
Yeah, it's basically segmentation fault style of crash. So it's not particularly safe.
No, I'm saying it's as soon as I can do that, the next step is I'll break your security without segfault.
Right.
Right. And I'll just
No, exactly.
read your
So
passwords and that kind of shit. Yeah.
the
Black
plan I
hat.
have there is to replace nil with an option type. That's mainly because it makes compositing behavior a little easier.
Yeah.
Because you can do things, chain things like X and then whatever.
No, I get the Kotlin.
And then the second stage is to introduce some form of runtime check, where it says, hey, if you told me this wasn't nil, but it actually is, produce a meaningful panic.
Yeah.
And then maybe a third option where it doesn't do that if you want to like really go for speed, but you're okay with the potential danger.
No, that would be the unsafe operation, which I'm claiming you should.
For example, right? And it will probably be some sort of explicit thing, not like a single character operator. But that's at this point sort of at the
with the strip a nil and panic if it is
right.
as a single character cleanup.
I
have a nil. So what you're saying is your range check turns into a nil, which I have to explicitly say, and panic me now.
Right. Yeah, and so I think that will be a pretty reasonable setup because the overhead of like is this nil it's not that big. It's an equality check on the pointer. That's it.
You're doing it in a hot graphics library mode. You won't want to do that.
No, for that case, you might have some sort of unsafe operation where you can say, no, look, this really is what I think it is.
Yeah, all right. There's a way to preserve speed and performance here.
Right.
The API gets a little wonky. This is exactly what I'm trying to sort. So the real answer is that you're not throwing an exception for a range check out of bounds. And I'm kind of going back and forth that you don't have to log you're throwing an exception, but a range check will throw. But I haven't figured out what I'm doing. I have a theory on what I'm doing for cleanup and catching those.
Right.
But I'm not
so the sort
proud of it.
End idea is that bugs, they will terminate, panic.
Yeah.
But reasonable errors, like timeouts, permission errors, that sort of thing, they throw exceptions.
Yes. Right.
Based
there's
on
a panic mode, and then there's a memory out of memory and Stack Overflows are both things that are extremely hard to recover from.
Yeah, they're panics.
So they're they're mostly panics.
And this currently the language does offer a way that you can sort of respond to those panics at a per process level. So you can say, hey, if this process panics, run this little function and then do whatever. But when you return from that function, it will still terminate. But I am considering kind of getting rid of that because there are certain panics where that wouldn't be safe. If you have some sort of memory corruption, like you can try whatever you want, but
panic on the panic.
Yeah. There was actually a bug where if you panic in the panic handler, it would get stuck in a loop.
Is that dim light there, Cameron, or dumb? Believe me, I have totally seen people write this code.
Yeah.
And been asked to do something sensible.
No, you're creating new memory because it's out of memory.
Yes, exactly.
Yeah. So the reason I haven't removed that yet is because this it kind of leads to the problem. Like, okay, let's say you have a function that could panic. You want to write unit tests for that.
Yeah.
If you cannot catch panics, how would you do that? Right. One approach, you just spawn a new OS process, run that code, and check.
That's what I've done.
Status. But my language currently doesn't have ways to spawn OS processes yet because I haven't written the code yet. And so, and I actually happen to have a couple of places where I tested like zero division errors, for example. They are panics. I want to test that. And so it's kind of at this point where I really want to remove these panic handlers because I think
you're correct. But that goes for every machine on the planet. We're all working with finite machines.
Yeah. So I want to get rid of that, but first I have to then implement basically POSIX spawn and do that on Unix, Windows, whatever platforms I want to support. And that's where it's like, I'm later. I don't want to deal with the POSIX APIs just yet.
Well, if the only goal of catching it is to do a unit test, I would just throw it on one machine that you're doing your development on and don't expose that API and you're done.
I thought for a moment, like, look, I can just test that once and sort of assume it will continue to work, but I know myself, I'll probably forget.
Yeah.
So since in my case, my work has been largely focused on the compiler, this is sort of on the side for like, I'll do that when the compiler is in a decent shape. Yeah, it's the whole error model as described by Joe Duffy and as I stole it. I think people will either really like it or really hate it. Like, I don't think there's going to be middle ground. People like, yeah, but no.
Right.
And I think that's largely dictated on where they are coming from. I would expect Java developers with their experience of checked exceptions to be reluctant, to be like, ooh. Whereas
what's good about it though is you made a decision. Like there's a reason for it. And that's the what I was saying earlier. What you don't want is to get backed into a corner by a lack of decision. So I mean, it's a very conscious decision. It's a conscious model, and you hold it consistently through the whole language. Then, it makes sense within that context.
Right. Yeah. So that's. I think it's probably one of the parts I like the most, just because you. Setting aside, bugs in the language, you cannot have unexpected runtime errors. So you can't have some random file system error just pop up in some mathematical loop because 50 layers down you call a IO function. And that just makes a lot of things so much easier.
I think it depends on what kinds of programs you are writing. Because things like file operations and IO and everything where you talk to complex APIs or the outside world, those can always fail. So it's really useful to force a programmer to address what should happen when this thing fails. But when you're writing mathematical code, you often have things that will always be right, like this index will always be in bounds, but it's not actually possible for you to tell the compiler that. And then it's really, really awkward if you constantly have to address to handle index out of bounds errors that will never actually happen. And if they happen, that's just a bug in your program, and you'd rather just have it explode.
Yeah.
That's where I was trying to corner you on, was take the runtime exception and explode for the range check exception and explode or not or something. But returning nil from an out of bounds on an array, I lived with that for a while, and that sucks.
Yeah, I have to admit, like the specific out of bounds case, I'm not sure yet. In the sense that like we have byte arrays and they will panic if you're out of bounds because there's no reasonable value that you can return. And I have been considering maybe we should make that consistent for arrays, but it's one of the things I haven't done it yet.
Well, any integer array, float array, return a 0. Is that what you just said? You return a nil or a 0?
I said for byte array.
Yeah,
byte arrays, it will panic.
Yeah, you can always return 257, but
what are you gonna do with long arrays, right? I got a bunch of UUIDs here, and I'm loading off the end. What do I get?
Right. Yeah, that's so I considering making that consistent, just haven't done it yet.
Okay, so some of your arrays panic, but there's no throwing and catching either. So the reason I'm bringing this up is because there's a tension here, which is I'm writing a web server that's going to run somebody else's program. Other developers are throwing things in. I take web requests, I fire them off. They throw an exception. I want to kill as much as I need to kill, reclaim all the storage, and then just go again, right? So I don't want somebody able to write a code that panics the entire server. Right. You're not allowed to panic the server.
But not every language needs to be able to do that.
No, it's fine. But if you make a conscious decision that says, I run somebody else's code, that code panics, down I go, right? Fine.
Right.
But
yeah, I think
you could hand code that just forked endlessly or threads or allocated memory to your out of bounds. There's a bunch of fail modes that are difficult to guard against at a language level if you're making a generic sandbox that you want to run somebody else's junk in your sandbox.
Yeah, I think the big challenge, I think, with these kind of models, solely for mine, is that if you have exceptions and panics, there's always the question, okay, should we panic or throw an exception? Because, for bugs, theoretically, there will be panics, but then you sort of still have sort of hidden errors that can pop up. Because a function might panic, if it divides by 0 or whatever. That's something where I'm not sure yet what the approach is. I thought for a moment, maybe should tag if a function panics, but then theoretically any function can panic because you might run out of memory.
So Java, love it or hate it, I worked through both Stack Overflow and out of memory, throwing an exception. So you actually get a valid exception if you are out of memory.
Right. Yeah. So I think that might work in a language where you don't have to tag exceptions or not as restrictive. But if you have a language like mine where you have to tag it, every function would have to be tagged as it might throw, a out of memory error.
Yeah. Or
and then you reach a point like if you always have to do something, it kind of loses its value.
Right.
At least it just becomes noise.
It completely loses its value. You don't have to write it anymore. You just know that everyone can throw, and then you're back around to everyone can throw.
Yeah, and so I for a moment thought maybe it should be well, that's basically I think there's no solution. Like if you have panics, they can pop up somewhere, right?
Yeah.
As the result of bugs.
I'm of the theory that I'm going to attempt this code has declared that it shall not panic, but then the code is limited in what it can do that it shall not panic.
Right.
And then you could write in a subset of a language that didn't do a panicky thing.
Right.
And then now how tight is that subset?
Right.
So it's like
it's essentially
two
like
different languages.
Well, as close as I can get to the one language, but say stuff like you can allocate, but only a finite amount. There can be no loops where you allocate. You can have a loop that can throw a range check exception, except you have to handle range check exception, however that's done internally, and turn it into an error that you're propagating up, right? Or turning it into an exception you're propagating, but not a panic. So range check does something else. I haven't sorted this one out to my satisfaction. I'm still sorting. I'm not sure what to do here. I don't want to have to annotate everything for range check. So range check turns into a throw.
Not to undersell myself, but I don't know if I'm smart enough to use a language that does what you just described.
Why?
Because it's a fairly complicated set of rules.
You mean the no panic one?
Well, just the entire, go left, and then if you see this, you can't go right. You have to go straight, but then you have to go left. It's the.
You don't have to say, I shall not panic. But if you're going to say, I shall not panic, you're limited. But then I could have a server that says, I'll only call code that does not panic. Right. And then we get away from the I can't write a server in a language because the code can, the sandboxed code can kill me. So I make the sandbox code not kill me by restricting it. Okay, that's fine. How do you restrict it? Well, one of the things to do is you put a language tag somewhere that says, you can't do these panic things. You can't call system.exit. You can't allocate forever in a loop. You can't spawn a thread. I don't know what the rules are. There's some rules, though, that says I can't run you out of resources in order to say you do not panic. And the goal there is simply to have code that can be called from, can be considered trusted, called from a guy who only calls trusted code. That's the goal there. I'm not claiming that's that's what you write all the time. That's not the case at all. You can write code. My goal is to have you write code that you've been writing for the last 20 years anyhow. Strong type safety, yada, yada. Do something reasonable with exceptions. Do something reasonable with these other kinds of panics.
Right. You want an escape hatch for your doubly nested hot loop.
Yeah, there has to be something there. So one of them is throw down. So what I heard Yorick say is throw down a one character, I got rid of the range check error that just says panic on range check, or turn it into a throw, but acknowledge that the compiler didn't know, the typing system didn't know there was no range check possible. The runtime has to know range check is possible and does something. So you had to tell the typing system it's okay. I would do that to be outside of the loops and say this loop can throw, they all can, but I want to declare it shall not panic. So at the end of the loop, there is an else clause that says, and if there's a range check, here's what I'm doing. But it's a short, very short thing. Or I put nothing down and I catch it right before I exit my module that says, if somebody throws a range check, the module converts that to an API fail. And the caller of the module is getting back a success fail message and he doesn't care for the exception. there's something there, right, that says I can call you, and then internally you do what the hell you do, and you optimize it reasonably well. You don't have to write horrible code everywhere to handle that, but that I can bottle up all the exceptions and cap them and say something fucked up, clean it up, and return a fail. And what's that look like? That's sort of a definite goal to be able to handle that situation well.
Yeah, we chose a something that's probably more like what York is working on in terms of the Inco allows you to basically spawn fibers, correct?
Yeah.
Yeah,
so,
more or less.
and we containerize, that is, we collect together under an umbrella of those. So what you're calling a panic would simply kill the container. And
Right.
You wouldn't see any exceptional.
Right. So you have a cap point for the exception. When the container
Right.
fails, somebody who called make me a container gets a message back saying this container would belly up.
Perhaps, yeah.
I mean, I assume that you don't want to silently drop the container on the floor.
No, I'm thinking more like, and I haven't used Erlang, but I'm thinking it's more like what was possible in Erlang with the, help me out, York.
Well,
Yeah, so they have supervisors, and if a process throws, because I don't think Erlang has panics,
yeah,
that throw is unhandled, it will just terminate that process.
And then it
you can
restarts it
monitor
or
that.
something, right?
Yeah,
Well,
you can do
it does
stuff
have
like
kind of panics, like an out of memory, it'll just kill the entire VM.
Yeah.
Right. It's yeah, yeah. I think put it this way, it's not really like part of the language. It's more like a segmentation fault, like it might just happen.
No, I mean, be careful here because segmentation faults are uncontrolled crashes that could, in principle, be exploited. The VM, the Erlang VM will do a control shutdown in out of memory conditions, so it's not a security issue. It might be a service issue, of course, but you can't take over.
I'm getting a phone call. Hello, Bob. Yes, Erlang will help you do that.
Yeah,
Okay.
so it's
for those of you that don't know, that's a reference to the old. They had the training video for Erlang. And, yeah, never mind.
Erlang the movie.
The Erlang movie. That's the one.
Yeah.
It's still on YouTube.
What was that phone?
There's a second one where they it's a parody where they try to rebrand it as Node.js. Yeah, so in Inco, it's currently a panic will terminate the entire program, which is rather extreme. You can scope it to processes. Thing there is, so if I remove the ability to handle panics, it will be basically terminating the whole process. So you can't have something, at least in that setup, where you have like a web server that spawns a process for every request. And then if that panics, you just, that's just that process. No, it will panic the whole web server.
Right.
And that's kind of why I haven't removed it yet, because I'm not really sure if people are going to like that. Like, I'm personally of the opinion that if it panics, you should terminate the process, and like an external supervisor, like run it, should do something with it.
Well, that means you didn't terminate the OS, but you terminated the process. And there's another piece of the OS, which is driving things.
The thing there's, I think opinions are very divided on that. And I haven't really been comfortable yet making a very strong decision there. So I kind of want to, I basically need to sit down and say, okay, are we going to do that? Or are we going to try and provide some sort of quote unquote recovery model for panics?
Right. And then what's a panic versus what's just an exception?
That's the thing. It's
found to an exception probably, but.
Right. And that's kind of my concern, because at that point, a panic is essentially a hidden exception. It's just handled in a different way. And I don't like that.
Right. Yeah. I'm there on that front. All right. We've been at it almost 2 hours, not quite. I want to do other things. So because I'm feeling the need to go run to the bathroom, I'm going to call it. And until next time, it's been very informative. This is actually kind of a fun go.
Actually, I have a really long conversation, Cliff, that I have to have with you right now.
I got bad news for you and my priorities. Sounds good.
Just like everyone else.
Save it for next time. All right, gentlemen. Hope to see you all next week. Bye-bye.
Stay safe.
All right.
Yeah.